Hello and welcome to the supplementary material for paper. LiDAR sensors are used in autonomous driving applications to perceive the environment. Their biggest advantage compared to, for example, camera and radars is that they provide precise depth measurements independent from the lighting conditions. They are, however, renowned to be negatively affected by adverse weather conditions like spray, rain, fog, and snow. Here, for example, we see a recording of vehicles driving on a wet surface. As we can see from the LiDAR point cloud, the LiDAR sensor actually measures many of the spray points in the scene. Here's an overview of our approach. Given a classification model F, which processes a point cloud P, we utilize our proposed point energy score to determine if a point was generated by adverse weather effect or not. To achieve this, during training, we minimize our proposed loss. This results in the model associating low point energy scores with inliers, such as, for example, pedestrians, vehicles, and buildings, and high point energy scores with outliers, which in this example is snow. During inference, we can choose a threshold tau, for which we decide based on the point energy score of each point if that point is an outlier or not. In the bottom right plot, we report with red points all of the outlier points detected. Let's see some of the results of our approach. Here we show our method when detecting spray. In the first plot from the left, we report the point energy score for each point in the point cloud. In the top right plot, we utilize the red color to detect which points were classified as outliers. And on the bottom right point, we simply filter all of the detected outlier points. Here we see an example of our method when detecting snow. Here is instead our method when detecting simulated fog on the new scenes dataset. One of the advantages of our method is the robustness to unseen weather effects. Here, for example, we report our method trained only on snow data and here tested on spray. Our method can be also used to perform simultaneous outlier detection and semantic segmentation. Here on the bottom left plot, we report the semantic segmentation results of our method. This concludes the supplementary materials for our paper, and we thank you for the attention.